So today we are doing Unit 4, Lesson 2. Can everybody on virtual see my screen? Okay, sounds good. I just want to double check with you. Alright, let's go ahead and get started. So, we're going to do the lesson. After the lesson or now, if you're on virtual, go ahead and type your name in the box for your attendance. So, we are doing Unit 4, Lesson 2. So, the first thing we're going to talk about is what the standard is, which states that your idea or your the concept here is to understand that a function from one set called the domain to another set called the range assigns to each element of the domain exactly one element of the range. So let's talk about what the domain is and what the range is. Guys, you shouldn't be on your phones. Alex, put your phone away. Domain is the set of all possible input x values of a function. Okay? So input values, we call these the independent variables. Okay? And the range is the set of y values used for the output of a function. And we call this our dependent variable. Okay? Dependent variable. So moving on. So we're going to look at a set of ordered pairs, mapping, and a graph, and we're going to determine the domain and range of each. So the domain is all the possible x values that your function is going to take. Okay, all the possible x values. So in this case, do you guys remember ordered pairs are always in the form x comma y? Okay, always in the form x comma y. So the first part of your coordinate right here, that's your x value, and the second part is your y.
So your range.
Yes. So domain are all the x's and y are all the range. So your domain here is 1, 2, 3, and 4. So I took those from all of the first part of the coordinate. Okay, that's your domain. Now your range
is
2, 4, 6, 8.
Good. 2, 4, 6, 8. So it's all of the second part of the coordinate, the y part. So 2, 4, 6, and 8. And we also want to identify back from your 4-2 lesson, is this a function or not?
Yes.
Yes, it is a function because it has all unique y values. No repeating y values to different, no repeating x values to different y values. So this is a function, okay? We learned about functions. All of the y values are different.
On Monday.
Yes, on Monday.
No, it's easy.
All right, you guys ready for the next portion?
Yeah.
So now we're going to look at the mapping. So you remember back to mapping. So with mapping, to identify your domain, you're going to look at each one of these that is used. Okay, if there's no arrow leaving from it, you're not going to list it in the domain. So is there an arrow leaving from each one of these values on the left?
No.
All of these are used, right, on the left?
Yeah.
Yeah, so we're going to list every single one of them. So 1, 2,
4, 8, 6, 8.
good, 4, 5, and 8, good. So that's all of my domain values. You only list them if they're actually used, so if there's an arrow leaving from those values, okay? So then from here, we're now going to identify the range. So the range is going to be all of the y values that we actually used.
1, 4, 7, 8.
Did we actually use the 1?
Oh no, it's 4, 7, 8. My bad.
Good. So we're not going to include the 1 or the 6 because we didn't actually use them. Okay, they're there, but we didn't use them. So the range here is going to be 4, 7, and 8. Makes sense to everybody why we didn't use the ones that were not actually basically used, okay?
But 7 wasn't used.
7 was used right here, see? The arrow coming out, into the 7 right here.
Oh.
You see it now?
Yeah, I see what you mean.
Okay.
Can I go to the bathroom now?
If you have to go right now, you can, but you're gonna miss this part. So now we're gonna talk about if it's a function or not. So, Paris, what are you doing? What do you need those for? Okay, so now let's determine if it's a function. So when the mapping situation, it's a function as long as there's only one arrow leaving from each x. What do you guys think? Is there only one arrow leaving from each x here?
Yeah.
Yes. See how there's no x where there's more than one arrow leaving the x? So this is a function. It's okay to have different x's go to the same y. This is okay. But it's not okay to have one x going to different y values. So it's okay to go to the same destination, but if you're, the x's you're leaving, you can't go to two different destinations at once. That's kind of the way we were putting it yesterday, right? So it's okay if we go to the same destination, but it's not okay, you can't go to two places at once. So now let's talk about from the graph. So this is where we're going to have to be able to identify an ordered pair from the graph in the form x comma y. So first thing we want to determine is this a function? Who thinks it is a function? Good. You guys are right. It is a function because it passes the vertical line test. Because there's nowhere that I could draw a vertical line where my function would hit more than one point, right?
How do you draw that so straight?
I don't know. It was magic, I guess. I got lucky. So this is a function because it passes the vertical line test. There's nowhere I could draw a vertical line where it would go through more than one point. Now we're going to list the domain, okay? So the easiest way to do this is to actually go through and identify what all of these x values are. Or all of these coordinates are. So 1, 2, 3, 4. So this coordinate is -4, 1, right? Everybody agree with that? This coordinate is 1, 1, 2, 3, 4, 5. Good. And this one is 1, 2, 3, 4, 5, 6.
Divide by 6/2. And
6,
like
2.
2 and 3, and 2 and 4.
Yeah, so this one over here is -2. We go over 2 and we go down 1, 2, 3, 4. -4. And then this one is 1, 2, 3. So 1, 2, 3. Yep, 3, comma, -2. And this one would be 4, comma, -2. So now that we've identified all of the coordinates of all of the points, we can now identify our domain and our range, okay? So the domain is going to be all of the x values. So we're going to put them in order, okay? So it looks like my smallest x value here is -4. What's my next smallest x value?
1. I mean,
-2, right?
yep,
-2, and then you're right, and the next one is 1.
and you positive 3,
+3,
4,
4,
6,
6.
right.
And that's it. And now we're going to do our range. So our range is going to be all of the y values. And you're going to go from bottom to top.
Yep.
So that's the second part of the coordinates.
Here's -4,
-4,
-2,
-2.
-2.
You only have to list it. That's a good point. So see how we have 2 at -2? We only have to list each range or domain value once if they occur twice. So I only have to list the -2 once. The next one would be 1, 2, and then 5. So these are all the y's. Okay, the range are all the y's. The domains are all of the x. Okay, does that make sense so far? You guys with me? You guys got this down? All right. Sounds good. So this is what we call a discrete graph, which is going to be points only. Okay, with the discrete graph, it's going to be points only. You're not going to be connecting the points. Okay? So we can list the domain and range of a discrete graph just like we did earlier. Okay, so we find all the coordinates. So 1, 2, 3, 4. So this would be -4, comma 1.
Why negative?
Because it's in the negative x direction.
Oh, yeah.
And then this would be -2, comma 1, 2, 3, 4. This is 1, comma 1, 2, 3, 4, 5. And this is 1, 2, 3,
And 6.
3, comma -2. And this is 4, comma -2. And this is, isn't this the same one we just did? 6, comma 2. So the domain, we call this D. is equal to -4, -2, 1, 3, 4, and 6. That's all of the x values. And your range are all of your y values, which are, these are both negative, yeah. -4, -2, 1, 2, and 5. So now a continuous graph appears as a line connected. So domain and range include the domain and range include intervals between the values, okay? So our domain here, so think about where this graph is going, okay? This graph is going in both directions forever. So will this graph eventually take on every x value if it keeps going? Yeah, if this graph kept going, it's going to eventually take on every single value, right?
Yeah.
So since it's going in both directions, my domain is going to be -infinity to +infinity, like that. And my range is going to be from, now we don't know if it's going to be a open graph here. So where's the lowest that my function goes? What's the lowest that it goes here? What's the y value of this?
Like 2.
-2, right? So my range goes from -2 to +infinity. So we use this bracket when this point is included. So you know how we use like a closed circle or an open circle? Okay, that means that that is included. Closed circle, it's included, okay? So you can write a note. These are for included, closed circle, and these are what we use for not included, open circle. Okay. So now we're going to talk about domain and range of continuous graphs. So when notating the domain and range of continuous graphs, continuous, I think that's spelled right.
It is.
We use these symbols. That's what I just talked about in the last slide. So the steps are to put your domain and range, y value in the middle, write the lowest, hang on. So you can use these values, but you can also use inequalities as well. So we'll talk about that too. So I'm going to write this with an inequality as well, the range and domain. No, well, that's okay. We'll do it on the next one. All right, moving on. So we're going to list out our domain and range. So these are both continuous, right? Because they're all connected. So my domain is how far from the x's it takes on. So domain is in the blue, okay? Range is top to bottom, okay, like this. So, for the domain, what's the most to the left the function goes on the x?
You said the most?
1, 2, 3, 4, 5. -5. So it goes -5 all the way to, and then it goes from -5 to +5. Okay? And that's what we call interval notation. Okay?
So 5 and 3?
-5 to 3. See how it spans from -5 to 3 on the x's?
Yeah.
And then it can also, this could also be written as -5 is less than or equal to x is less than or equal to 3. So those are the two types of notation that you can see here. And now we'll talk about range. So range is up and down, the y values. So what's the lowest y value this function takes? Or this relation, rather, it's not a function. What's the lowest that this goes?
0.
It goes down here to 0? It goes to 1. So from 1 all the way up to 1, 2, 3, 4, it looks like it goes to 5. I kind of drew over it, so. Not quite to 5. It goes to about 4.5. Good. 1 to 4.5. Or you can write it as 1 like this. 1 is less than y is less than 4.5, meaning your y value is between those two. And then the next one we're going to look at is going to be this one right here. So this function goes on forever in both directions, right? Both directions forever, okay? So this one's going from -infinity to +infinity. And the range as well is going from -infinity to +infinity. And this can also be known as, they might write it all real numbers. Okay, all real numbers. All real numbers. So with domain, you're only worrying about x values. Yeah.
No.
And with range, you're only looking at y values, okay? X values versus y values. So that's all you look at when you identify. And you can give me interval notation. So this is interval. And this is inequality. Interval and inequality.